Hi Math 111. This is our second video for section 1.1, and in this video we're going to talk about two ideas. We're going to talk about what's called the distance formula and midpoint. So what we'd like to do is, if we have 2 points in the xy plane, we'd like to find the distance between those 2 points. And sometimes this can be a fairly straightforward calculation. For example, what if I have, I don't know, 2 points, maybe one here and maybe one here. Okay. And let's say that, this is 1 and 2, 3, 4, right? So these 2 points are directly across from each other, right? It could be pretty easy just to look at this and decide how far apart those 2 points are because they're directly across from each other. How many units do I have to move to go from one point to the other? Well, if I start at this point, I just go over 1, 2, 3 spots, right? I just move over 3 tick marks. So that means that the distance between those 2 points is 3, right? So if I wanted to call distance d or something like that, right? I could say that d would equal 3, right? Right? Or the distance between the 2 points would be 3. And the same thing sort of applies if we had 2 points which were stacked vertically on top of each other. Geez. Oh my goodness. These 2 points here are stacked directly on top of each other like this, and because they're directly on top of each other, if I think about moving from one point to the next, it's just a matter of counting at this point. If I start at this one, I go up 1, 2, 3, and again 3 units apart, right? So again, the distance in this one is also 3. That would just happen to be coincidental, right? But anytime the points are not directly stacked on top of each other or right next to each other, it gets a little bit trickier, right? So let's consider an example. Okay, let's find the distance between 2 points, and I'm going to give you the 2 points. Okay, so here's the instructions. We're going to find distance between, and here's the 2 points. They're going to be 1, 2, and 5, 5. Okay, well let's plot these points and in the last video, remember we said that plot meant locate them in the xy plane. So let's plot these points and see exactly what they're looking like. I'm going to try my best to make these really straight lines. Okay, so let's locate this first one. I go over 1 and up 2, so that point would be here. And then the next point is over 5. 1, 2, 3, 4, 5, up 5. 1, 2, 3, 4, 5 here. Get that thing out of here. And these 2 points, notice, are not directly next to each other. And they're not directly on top of each other either, right? They're sort of, if I thought about how far apart they are, that's really calculating the distance between the two, right? So if I use a different color, right? If I sort of made the line between these two things right there, I need to know the length of that line to know how far apart they are, to know the distance between the two of them. Okay, well, we could figure this out using some techniques we have from geometry. If we remember that if we look at this right here, it actually is part of a triangle, right? So let's see. If I were to connect like over here and down like this, right, and make this a little right angle right there, notice that what that pink line is, the distance between the two is actually the hypotenuse, remember, of a right triangle. Okay, and we know something special about right triangles. Remember, we have what's called the Pythagorean theorem, right? And the Pythagorean theorem says something about the relationship between the sides of a right triangle. Remember, it says if you if you sum the squares of the legs of the right triangle, you get the square of the hypotenuse. Or you might probably remember it as what? A squared plus b squared equals c squared. Right, where A and B are the sides of that right triangle, and C is the hypotenuse here. So this would be like A, and this would be B, and this would be C. Well, that means I can find out what C is if I know what A and B are. Well, notice that A and B are actually just like what we did up here, right? They're lengths that are horizontal for A and vertical for B, right? A is a horizontal length, B is a vertical length. So what that means is that I can just count how long those sides are, and then I can use those to find C. So notice that A here, let's just count it, is 1, 2, 3, 4, right? 1, 2, 3, 4. So A is 4. So it's 4 on this side. B is 1, 2, 3, so that's 3. And I don't know what C is. We're going to find that out, right? Okay, well, let's plug in those numbers for A and B and find out what C is. So it says if I square A, so that means I do 4 squared, and I add B squared, which is 3 squared, I get C squared. Okay, so this is what, 16 plus 9, which is C squared. So 25 equals C squared. Okay, so what is the value of C if C squared is 25? Well, that means that C could be, if you take the square root of both sides here, right? I could get a different color for you. Okay, if I take the square root of both sides, okay, that means that I could have C being plus or minus 5, right? Because remember, when you take the square root, you actually generate a plus or minus 5. But it doesn't make any sense for C to be minus 5 because it's a length, right? So we just get 5. Okay, so that means this length here is 5 units, right? If you were able to sort of lay this side down flat, it would go 1, 2, 3, 4, 5 units, right? If you swung that down and laid it flat, it would be 5 units long. Okay, and this process can be completely generalized, right, for any 2 points that actually live in the xy plane, right? It's kind of messy and a little bit, I don't know. You might not want to see it. If you want to see it, I can show it to you in another video. But let me just give you the nutshell of how that works, right? And I have it over here in a nice little PowerPoint for you. Okay, so let's say that I have 2 points, right? Let's call them P and Q. And I've labeled them because I want to be really general here. I don't know what my points are going to be called. They could be 3, 5 and 1, 2, or 1, 2 and 5, 5, like I have in this example over here. But we don't know. We want to make this really general so I can use this formula I'm going to develop for any 2 points in the xy plane. Okay, so the distance between 2 points P and Q, where P is given by AB, Q is given by CD. Your book uses slightly different letters, but that's okay. The distance is going to be given by the following, and it's similar to what we did over here, okay? We involved a square root here, there was some squaring action of things in addition, and those are features you're going to see in what this formula is right here. Okay, so here's the distance. There's a square root. That's because we made use of the Pythagorean theorem, and that's that same square root right there. And then we have the sum of 2 things that were squared. That's the sum of 2 things that were squared, okay? So this right here, this formula completely comes from doing the Pythagorean theorem, right, in a general way. Okay, and this is the formula we can make use of. So if we want to find the distance between 2 points, we can just plug it right into this formula and calculate it. Right? So let's give that a try with an example. Okay. So let's try finding the distance between 2 points. So let's use the points 1, 3 and -2, 6. Okay, let's find the distance between those 2 points. Does it matter which one we call point P and which one we call point Q? Nope, doesn't matter at all. Okay, but just so that you're aware of what I'm going to call what, let's call this first one the point AB and the second one the point CD. Right? Doesn't matter which one, if we don't have to use the P and Q part. We just want to know what A, B, C, and D are. Okay, so A is going to be 1, B is 3, C is -2, and D is 6. Okay, so now we can just plug it right in, right? We could make a graph first and go through it doing the Pythagorean theorem like we did before, but again, we've generalized that process here, right? So let's make use of our formula. So the distance between those 2 points is the square root of, make a big square root. I do A minus C, okay, so that's A minus C. So 1 minus, C is a -2, so again, be very careful, you're subtracting a negative. And I square that thing, right, because of that square right there. I add to that B minus D, the quantity squared. So B is 3 minus D is 6, the quantity squared. Right? Notice that this is really what? The difference of the x coordinates, the difference of the y coordinates, right? You square those things, add them, and square root it. That's really what's going on here. So if you just think about difference of the x's, difference of the y's, you'll sort of remember what the formula looks like. So let's carry out the arithmetic here. 1 minus a -2 ends up being 1 plus 2, right? This is really 1 plus 2. Okay, so what that means is that we've got 1 plus 2, which is 3. So I want to square that. So 3 squared is 9, right? So that's again 3, and you want to square it, which is 9, plus 3 minus a 6. What is 3 minus 6? Well, 3 minus 6 is -3, right? So this is -3. And we need to square that thing. Negative 3 squared is another 9, right? So we've got 9 and 9. Okay, that one's 9 because it was 1 plus 2. This one is not squared. And this one is 9 because it was 3 minus 6, which is negative 3 squared. Okay, so 9 and 9 is 18, and so we have the square root of 18. If you'd like to leave it like that, that's fine. It's a number, right? If you'd like to get a decimal approximation, that's also fine. If you'd like to simplify the radical, that's also fine, right? Because remember from our Math 95 stuff, we could simplify this radical by noticing there's a perfect square living in 18. So this is 9 times 2. 9 is a perfect square. It comes out as a 3. So this is 3 square roots of 2. Okay, and that's the distance between these 2 points if you connected them with a straight line. Good. All right, well, let's move on to our next topic for this video, our second topic. This, we're now going to talk about what's called finding the midpoint of that line that does in fact connect 2 points in the xy plane. Okay, so if we wanted to think about this, we can develop just a quick little formula to calculate it, and this one's actually pretty easy to remember. So let's say we wanted to find the midpoint, and that's going to be a point, remember, because it's going to be a point in the plane, the midpoint of a line segment connecting 2 points again. And I kept it really general to make sure that this applies for any 2 points that we have on the xy plane. So this one is going to depend upon being able to calculate averages, right? So remember, to calculate an average, you just add up the number of things you have and divide by the number of things you added, right? So here, notice that we have, to find the midpoint m, all we do is we take the x coordinates a and c and average them. Remember, an average is you add them together, divide by the number of things you added, so a plus c over 2. And to get the y coordinate of the midpoint, you just do the y's averaged, so b plus d divided by 2. Okay, and let's try an example. Okay, let's find the midpoint of the line segment connecting 2 points. How about, let's make the 2 points kind of interesting. So how about 2.3 comma negative 1.4, and the second point will be 0.7 and 1.2. Okay, so these are our 2 points, and we want to find the midpoint of the line segment connecting the two. All right, well, let's choose to label them as A, B, and C and D, just so we can remember what we're using here. So this is A, B, and we'll choose this as C, D. Again, it could have been the other way around. This could have been A, B, this could have been C, D, it doesn't matter. But the midpoint, M, it's going to be an ordered pair, remember, because it's a point in the xy plane, the point halfway between the two. And what do? I average the x values and average the y values. Okay, so I average the x's. I do 2 plus 3 plus 0.7 divided by 2, comma, that's the x, going to be my x coordinate, and I average the y's. Negative 1.4 plus 1.2 divided by 2. Now we just got to do a little arithmetic. Okay, 2.3 plus 0.7 is what? 3 divided by 2, so 3 halves. And negative 1.4 plus 1.2, well, that one doesn't quite take over that one, right? There's a little bit of negative left over, right? That's actually what? Negative 0.2 left over 2. And if you like, you can write these in a little bit simpler form. 3 halves is 1.5, and negative 0.2 divided by 2 is negative 0.1. And so that's the ordered pair, which represents the point halfway between these 2 points. If you graphed these 2 points in the xy plane, if you plotted them, this point would be exactly halfway between the two of them on the line segment connecting the two. All right, so that's it for section 1.1 for right now. There will be one more video on this section talking about a graph and xy intercepts.